Hi everyone, welcome. I hope you were all satisfied after lunch. So I figured I'd quickly introduce myself. I've been playing around with Linux since about 2002. I finally got a job doing systems administration after attending lots and lots of Linux users group meetings and playing around with a lot of my own servers in 2006. I've also been working with open source for about the same amount of time, since 2005, 2006-ish. I'm a contributor to Ubuntu, and last year the 8th edition of the official Ubuntu book came out, which I'm one of the co-authors of. I've also done work with Debian, and these days I work at HP on the OpenStack project. But for this talk, the thing that's probably most relevant is I'm a member of the OpenStack infrastructure team. That's not actually part of HP. I like to tell people that HP donates me to OpenStack as a systems administrator. So don't ask me any HP questions. I don't know what's going on there. I just work on open source. The OpenStack infrastructure team is made up of, I think it's actually over 100 repositories that are all public that make up our infrastructure. This is CGit here, which shows all of our projects. If you can see this all here. We have a lot of Puppet modules, and then we have some of our own projects that we wrote ourselves that I can talk about. So we have a lot of projects. Our entire infrastructure is open source, and we have a mandate from the OpenStack Foundation to only use open source software in our infrastructure. Part of this is because the OpenStack project has contributions from over 100 companies from around the world, and if we picked one particular tool and started paying for it, chances are there will be a conflict with one of the companies that is part of the OpenStack project. So we try not to play favorites with regard to paying for software by avoiding paying for software entirely. Of this OpenStack infrastructure team, there are 6 of us spread around the world. There's actually 4 of us in the United States, 1 in Australia, and 1 in Russia, who have root access to all of the servers in the infrastructure. And then there are 7 of us who can actually commit code directly to the repository once it goes through our code review system. Beyond the 6 or 7 of us, there's also a whole fleet of contributors who contribute small patches here and there, and who are also a major part of our team, who contribute a lot more than that into our system. So I didn't know if we had internet, so that's a screenshot of our repository there. So I wanted to begin by talking about why we open source infrastructure and why this is an interesting topic for people who may not be working on open source projects. I was really excited to hear from Jason this morning, I think that's his name, about how he lets developers have some tools on some of the servers to run Puppet commands and test the infrastructure and things that they're deploying against so that they understand what's going on, because that is a major part of why we're doing this. The story of how we came to open source our infrastructure sort of came as we were working as a normal open source project where there's typically a company or some sort of small team of systems administrators managing the infrastructure or hosting it on something like GitHub. People would submit tickets to the infrastructure team, and then we would perform things for them. We'd add their new project, or we'd do something to make a change. Someone would have a CSS fix for the OpenStack planet. They'd put it into a ticket, and we would fix it. We realized at some point that was really silly, and we should just have people submitting code directly to us. We couldn't use GitHub because, again, we can only use open source, and GitHub is a proprietary platform. So we had to come up with our own solution. Fortunately, we already had the OpenStack developer workflow, which has a continuous integration system, a code review front end, and does a lot of automated tests. So for us, making our infrastructure open source made a whole lot of sense. We still respond to support tickets, but people can just submit patches directly themselves, which for an open source project is great. And if you have an organization where you have developers inside your organization who want to submit patches, that is great too, because they don't need to submit a ticket. They can write a patch if they have time. It's also great for priorities, because sometimes the ops team does not have a priority that the dev team has. So if the dev team really, really wants a new feature, but the ops side says, hey, we don't have time or budget for that, the dev team can then make a decision to spend the time to develop something for ops and then make a contribution through a code review system or a pull request or whatever you're running inside of your company. Something I also enjoy about our infrastructure is that I really like examples. Sometimes I'll pull down a Puppet module from the Forge or from GitHub or somewhere, and there will be variables. There'll be variables like host name, and I'm like, is that like the computer name or the fully qualified domain name? Or things like SSH key. And I'm like, well, is that a file or is that the contents of the SSH key? And I'm not really sure, and sometimes I have to do testing to figure that stuff out. In our infrastructure, we have both our separated Puppet modules, which I'll talk about, and then the OpenStack specific stuff. And I'm going to try to exit out of here again, and maybe we can get back to it eventually. So I can show you. I should have a link to it later, but examples are good. We also found that sharing our infrastructure with the entire world makes us do Puppet better, eventually. When we first were learning Puppet, things were sort of thrown up and it was a little crazy and people would laugh at us. But as over time, we started doing things like adding tests. There was a talk this morning that talked about using things like Puppet lint, and we use Puppet parser validate and Beaker RSpec on some of this stuff to actually apply the things on servers and make sure they apply properly. So over time, we've had really consistent Puppet code, and it makes our lives so much easier. When someone new comes to the project and they look at a config file, they know that it's adhering to certain standards that we've put in place. Also, when we finally upgraded to Puppet 3, which was in September when we realized Puppet 2.7 was going away, we were like, oh no, what are we going to do? But we upgraded it, and it wasn't actually that bad, since we had already been getting rid of deprecated things and sort of keeping up with best practices as we knew them. I also touched upon this, others in your organization can suggest changes if the infrastructure is made available to them. Of course, in our case, it is the OpenStack community and pretty much the entire world, since anyone can submit a code change to the OpenStack project. But inside your organization, if you open this up to people who want access to the code repository, they can make suggestions as well. I also want to say that sharing is nice. I got into open source because I actually believe in open source, and I'm really excited to actually have a job where I can get paid to do open source, especially in systems administration. The team that I work on, 4 of us of the root team, we actually work at HP. No, I think 3 of us. And then 2 of them work at the, what is that? No, I think there's only, I can't remember now. 3 or 4 of us at HP. 2 people at the OpenStack Foundation, 1 person at Rackspace, and another guy at Mirantis. So we're from companies all over the world, and then there's people from lots of other companies making changes. And all of these people that I work with on a daily basis, they really believe in open source. There hasn't really been a problem with us requiring open source because it's sort of something we all know. When someone comes into a meeting and suggests a proprietary solution, we're just like, no, we don't do that. So for us, we really believe in open source, and we're a really solid open source team, which is something I was skeptical about coming to HP, because I was like, HP, are they doing open source for real? It turns out there's a whole group of us who are, and I'm sure there's other pockets within the company who are doing it really well. So I also want to walk you through how we've actually gone about this. And this is sort of an index of what we will talk about here. So for us, the first thing we did was have an open source policy. This is obviously not feasible for a lot of companies. You sometimes have to keep proprietary stuff separate from all of your open source stuff. But for us, it was easy. We can put every single config file that we use on the internet. We can share things with whoever we want. As far as proprietary software, it's kind of unclear whether configuration files are usually licensed by the company. You would probably have to check with your sales representative or someone at the company you're working with to figure out whether those configuration files are proprietary or not. Because it varies by company. Sometimes they will have no idea and be like, what are you doing? Why would you put our config file on the internet or share it with your entire organization? But This makes it important to separate out the proprietary because you don't know what you're allowed to share, or it's really hard to find out what you're allowed to share. So the first thing I suggest is if you want to open source within your organization or within your company or with the world, first put the proprietary stuff in a different repository, just so you don't accidentally share that with people you're not allowed to share it with. Another one is licenses. I really like it when people add licenses to their config file or their Git repository. It's not something that GitHub requires, and I really wish they would require one. But I can't count the number of times I have found a Puppet module that I really want to use, and either I can't find a license in the code, or they have conflicting licenses in their code. So routinely, I'll do pull requests that just add a license file, or I'll email the maintainer and say, hey, can I use this license, or can I use this, and what is the license? And they'll make the change. And every single time I have reached out to contact someone about that, they say, of course it's open source, it's GPL, or it's Apache, or whatever, it's something I can use. But given my role at HP, and my role at the OpenStack Foundation, it is essential that we know what the license of a file is. And I found that systems administrators are often not so attuned to this. Licenses seem like they're for code. They're not for Puppet configs. But they actually are for Puppet configs, especially if you're sharing them. So don't make me email you to ask you the license of your module. Please include that on your own. So then we can use it. So on the Puppet side, there were a few things that we've done and a few things that we've improved on over time to make sure that our infrastructure was a good open source project itself. The first one was making a lot of use of existing modules. So you have things like Apache and MySQL. You probably don't need to write your own Apache or MySQL module. You can look for, audit, and use one of the existing modules on the Puppet Forge or something someone put up on GitHub. If it doesn't do what you want, you can contribute to the project and see if they'll add your feature. If it still doesn't do what you want, you can still possibly use part of that module and then just add your own pieces on top of it, like locally patch it. But I strongly encourage using existing modules. This is something we did a really poor job of early on. We forked a lot of modules. We're using an Apache module from like 1912. It's a really, really old one, and now we can't upgrade it. That's a very unfortunate thing. We actually had to change the name of it because some of the other modules that we're now using depend on newer Apache modules. So I think we're now calling it like OpenStack CI _ HTTPD or something. So that was a big mess. But we're getting better. We're using more upstream modules. And the really cool thing about using upstream modules is you can also pin it to a specific version in your Puppet config. So we're actually using a Java applications server called Wildfly for one of our new applications. And it's like, I think it's like one guy working on it. He was really excited when I emailed him and told him that, actually I emailed him because I needed a license. And he was like, oh my gosh, someone else is using this, awesome. But as a result, he kind of makes changes really fast without thinking of other people. He now includes in change notes what's going to break, which I really, really appreciate, but we still pin on a specific version inside of Puppet to say, like, we are going to use this module and no other module. So we'll upgrade on our own. I included something called Review Day here. That's an example of a module that we wrote in-house for a tool that it actually goes through Launchpad bugs. Launchpad's a bug tracker and a whole lot more. And correlates that with reviews in Garrett, the code review system, to give developers a list of bugs that they should be, or reviews that they should be prioritizing. And when I wrote this module, I was like, hey, someone else could use this someday. So all of the modules that we write, we try not to include any OpenStack specific stuff in it. We put that out into our own module. We also, early on, we had all of our Puppet modules, all those terribly forked ones that we had, they were all inside this massive thing that we called config. So when other people wanted to use our continuous integration system and our infrastructure, which we now have people using, they had to download our entire Git repo with all the history and all the junk that they never want to use. We have things like Etherpad and wikis and IRC bots. And it turns out inside of HP, where they're using part of this infrastructure, they don't want all that stuff. So we've since separated all the modules. So don't do the big config thing. That was a big mess for us, which I talk about here. So one of the first steps of breaking out all of this stuff and making sure we have much less of a mess is separating out our system config, which is all of our servers, from our specific project config, which is all the OpenStack stuff. So we have a system configuration, which will define all of our files and all of our templates for things like Jenkins and Garrett, our whole continuous integration system, all the wiki stuff we're using, all the IRC bot stuff we're using, all of the servers that we need to run live in this configuration. And then inside of that, there's this little OpenStack project module that we expect operators to replace with their own module. We then have a project configuration, which sets up all of our Jenkins jobs. It tells Garrett what projects exist. I think it also talks all about the specific IRC channels and other things that the bots need to join for the OpenStack project. This has been a huge thing for our downstreams because, as I mentioned, they were downloading this giant config repo before, but now they're downloading system config if they just want our server stuff. And then they're looking at our project config to figure out what kind of Jenkins jobs they want to define, what kind of Garrett projects they want to look up. And then again, they have examples. They see how all the OpenStack projects are defined. So if our documentation turns out to be a bit lacking, they still have production examples to look at. We also use, we also make sure we split out the non-sensitive custom configuration stuff. So as I mentioned, there's an Apache module, but if there's anything site-specific, we put that in our own module. I have an example here of a tool called Zool, which we wrote in-house. It is a gatekeeper. If anyone's watched Ghostbusters recently. Zool is a tool that's actually used by a few people, other than us. It talks between Garrett and Jenkins. There's a Garrett and Jenkins plugin, but the volume of changes that we have made that insufficient for us. We're processing thousands of changes a day, so it would fall over pretty quickly. So we developed a tool called Zool, which not only interfaces between Garrett and Jenkins or whatever test runner you're using, it also makes sure that the changes that are incoming, since your test last passed, that they're sort of stacked against each other, so you won't have conflicting patches merging at the same time. Zool makes sure that that doesn't happen. It will also handle trying to resolve really basic merge conflicts. But anyway, the point of this is that we have this Zool production file. And in it, we put all of our site-specific stuff. So we have a Zool Puppet module, and then this is the one that's inside our OpenStack project module. So we have things like the status URL for Zool, which is an OpenStack URL. We've got things like the IP address of our Garrett server hard-coded into this. And this is an interesting story. We migrated our Garrett server on Saturday to a whole new system, because that's what we do instead of upgrading Ubuntu. And so we changed the IP address. So when I was preparing for this talk on Monday, I opened up this file, which I used for my example file, and I said, we still have review.openstack.org in there, which works fine if DNS doesn't die. But we had the old IP addresses in here. I'm like, I can fix that. So I did, and my change went in. So yay, when DNS dies, because that never happens, we can still connect to our server. Anyway, this file has a lot of stuff that's specific to our configuration. I will mention that one of the things we learned early on is that even though we're an open source project and all of us participate on open source mailing lists with our email address out there in the open, we consider email addresses as private information in Puppet configs. Does anyone know why? Okay, it turns out people will download and run your Puppet manifest without reading them. So, when we had our email addresses in here, we would start getting emails from people's infrastructures at all kinds of interesting companies. So, we ended up seeing their host names, and we're like, oh look, AcmeCo is using our infrastructure. They're testing it out anyway. And it was really funny, and it was really great for like 5 minutes, but then we'd have to like actually contact the company and tell them to stop like emailing us because it was getting a little absurd and they were doing something bad because we were learning things about their infrastructure we probably shouldn't learn. So even if you think email addresses are, you don't put them in here because people do crazy things with running Puppet modules. It's a little scary. Wow, it's going away again. There we go. So we split out all that, and then we put in our own custom module, which another company or organization or whoever can replace with their own when they're using Zool or whatever. So we use all kinds of variables all over the place, which includes using Hyra. For our management of Hyra, we keep it in a private Git repository that only the root admins have access to. So if someone wants to launch a new service in the OpenStack community, they can do that, but they're not going to email me a private SSH key. They're going to come to me and say, hey Liz, can you can you give me a variable to use in my Puppet config? And I'll go to the Hyra server and I will add in the Hyra thing and I'll give them the variable to use in their Puppet config. So there's no, there's a bottleneck of there only being 6 root admins in the world. But in general, it works really well for us because, of course, it's in a Git repository that we back up, and then we don't need to ship around private data. We just give anyone who's working on our infrastructure a variable to use. So, like, a Garrett private SSH key is the variable that they use, and they never know what the SSH key is. They never see the SSH key, and that's one of the things we try to do to keep our infrastructure a bit secure. I will mention that as an open source project, who has all of our infrastructure on the internet and anyone can duplicate it at any time. It's kind of funny to talk about being secure because everyone knows exactly what version of everything we're running. But nothing bad has happened yet. Well, sometimes people take down our Elk stack, but just because complex queries are hard. So another thing we do is we set up a thing called Puppet board. This is really helpful. It's a dashboard for Puppet stuff. I can show it to you. Again, it's open source because that's all we use. It does require Puppet DB, but we weren't using Puppet DB at all, and actually implementing it wasn't a huge deal when we decided we wanted to use a dashboard. So in here, it shows you what's going on with Puppet on all the servers. So instead of doing something crazy like publishing syslogs or having people come into IRC every time they wonder if their Puppet change has been applied, they can just check the website and see if their change has gone in. There was one, oh, here's a failed one. So this is on one of our git.openstack.org servers, and you see my name in here a lot. That's because I was added as a root admin like 2 months ago, and on this server, the GID that we're trying to add my user in is actually used by another process for some reason, or another user or group for some reason, and we haven't really gotten around to fixing that. But this is a great example of it not working. But it shows you what failed, right? Like in here it tells you could not create group Elizabeth because the GUID is already in use. So instead of scouring logs or asking someone to do it for you, you can just go into Puppet board and see what the results are. I will mention that we're running this public on the internet, so we turned off querying because that would be bad. Turns out queries tell you way more than we should be making public. But you could run something like this inside your organization. So in our case, the code goes into code review, runs all those Puppet tests to make sure it actually works, and then gets merged into the repository. But that process of being merged in, it depends on when the Puppet run goes, when it actually gets into the Git repository and is replicated. So it could take, at most, I think, about 35 minutes from when your code goes in. So if you're really excited and waiting for a port to open up on that server you just launched and forgot to open a port on, you don't need to be like, hey, did the Puppet change go in? Did the Puppet change go in? What happened to it? You can just come here and see what's going on. And then you can write your change yourself. Oopsies. Right, so that's what Puppet board looks like. Big fan. And then pretty much the final step here in getting this all prepared for people to use is sharing it in some way. with a license, please. And part of that sharing is making sure you have documentation. The first, perhaps obvious part of this is make sure you have links to the source code. So whether you're using Git or something else, make sure people in your organization know where to find that. You also want to tell people how to make changes to this configuration. So in our case, in the OpenStack project, it's the same as making a change to any other project. And so we have instructions here. We have a website, ci.openstack.org, which has a lot of documentation. If you look at my commits for the past 6 months, I'd say about 70% of my commits were just documentation changes, because I'm kind of the documentation person on the team, it's turned out, just because I don't mind doing it and everyone else hates it. We have things here like making a change in Puppet. So there's a lot of words which are actually important, but we won't talk about them now. But the point of this is that if someone wants to make a change into our configuration and they want to know like what modules we're loading up and how we're installing Puppet, what version of Puppet we're using, what operating system we're using, we give them instructions here on how to replicate our setup, whether they're doing it in OpenStack Cloud or in Vagrant or Docker or whatever. We first tell them, install the latest Ubuntu LTS, and then we give them a series of commands to run. So they're, sudoing to root, installing Git, grabbing our repository, and then using a couple of scripts that we put together to install the Puppet modules with the right versions, and actually install Puppet itself. And then we give them instructions on how to create a basic, like a local.pp file that they'd apply, and then how to run that with Puppet apply. So instead of actually giving people logins to our servers to run test applies and stuff, we just tell them to create their own development environment. And this works really, really well, especially when people are creating complicated commits and they want to make sure it all runs in our infrastructure. So we make sure that is documented. We also have, as I said, directions on how to contribute. For us, it's through code review. In your organization, it may be everyone has commit access to the repository and it gets tested later, or they have to do a pull request that gets reviewed. You may want people to submit things to as a mailing list attachment or bug report or whatever, but make sure people know how to make a contribution, because otherwise you'll get random developers emailing you really huge patches, and you'll be like, "I'll worry about this later," and then it never happens. And then in general, some of the bootstrapping and glue that goes into your network or your configuration. I mentioned we have ci.openstack.org, where all our documentation lives. And we have all kinds of information here. We have stuff that's root only. Recently our backup server filled up, and we apparently don't believe in alert monitoring. So when I was added as a root admin, I started getting all the root emails, which is always a fun time. And I was like, hey guys, first of all, one of our backup servers disappeared because it's the cloud and sometimes that happens. And the other server is full and all the backups are failing. And they're like, oh, that sucks. You should build a new one. So that was one of my first things that I did. I built a new backup server. But it was great. We have all this like sysadmin specific documentation, so you can see how we do all this stuff, like our backups. You can see where our backups live. Actually, the AZ one is not there right now because that's the one that it disappeared. I haven't rebuilt it yet. But we make public all of our documentation. It's not in a wiki. It's actually RST. That's part of our system config thing. But that's sort of like glue that holds our infrastructure together and covers important things like here it's launching new servers and how we enable Puppet, because we run Puppet regularly, but sometimes you need to disable it if you're going to try to test something. Cinder is a volume thing in OpenStack, and we attach Cinder volumes to some of our servers, like our log server has like 17 terabytes of space, and that's actually a bunch of Cinder volumes on LVM. So it's just like a big LVM group that has a bunch of volumes attached. So we give ourselves instructions on how to do that. So when it happens and we're tired, we don't have to remember the commands, we just have them. I mean, normal sysadmin stuff, right? But we have it all in public and we make sure it's documented so other contributors in our team or in your organization know how things are working. So OpenStack does this crazy open source CI thing and open source infrastructure thing, but we're not the only ones. There are some other projects that use Puppet and are open source projects. Debian is one of them. The Debian Systems Administration Team, dsa.debian.org, that's a bunch of volunteers that manage Debian's infrastructure. Mozilla has this Puppet Again project where they're using Puppet in their infrastructure in some way. I haven't talked to anyone there about it, but I learned about this and they told me about it, so I was like, oh, cool. Jenkins itself, their infrastructure is also managed by an infrastructure team, and they use Puppet. And the really interesting thing about all these projects for me is that I worked on open source and sort of dabbled in systems administration for 4 years before I found a job. When I found the job, my first job there was racking and installing servers, which was fine, and it was great, and I knew how to do it. And that's sort of where you start as a junior sysadmin. At least you used to before we had clouds and things. But these days, you can join an open source project. If you're like me, I was working as an accountant and playing with computers in my free time. These days, I could have been actually contributing to an open source project, getting experience with a real infrastructure, and never having to be hired by anyone or pass an interview. I submit code to a project, it gets approved, and I'll mention that at least with Mozilla, Jenkins, and OpenStack, if you start getting involved in one of these projects, and your volume of work keeps increasing, we're still at a time where a lot of companies will hire you to do this professionally. Like, these teams are so understaffed that we need people who are interested in working. So I don't ask people to work for free, but if you want to work for free because you want to learn stuff and not pay to go to school, it's a really nice way to get involved in a real world open source infrastructure that you can learn from. And that was the last of that. The things I wanted to mention on this last slide here are a couple of specifications for how we got ourselves into shape. I mentioned that we split off our project config and our system config. And in order to do this, OpenStack has a 6-month release cycle. So for each cycle, we don't really commit to that so much because as an infrastructure team, we don't release every 6 months. We just support OpenStack all the time. But we go through a specification process like the rest of OpenStack, which scopes out work that we're going to complete on a certain schedule. So in this one, it was a specification to say, listen, we want to split out the system config and the project config. And we went through and talked about all the stuff we're splitting out, how the implementation works, who's going to be assigned to it, some of the work items defined. So that was good. But the really interesting one is when we split out all of our Puppet modules. This is a much longer specification, but again, all of our Puppet modules were stuck in one main repository, and it was really hard to manage them and for people to take care of them. Monolithic, awful thing. So this one was interesting because as we worked on this project itself, we updated the specification with all of the steps that we ran. One of the things we wanted to do is we wanted to preserve the Git history for all of the modules that we were importing into their own separate project. So we have all the fancy Git commands that we used to pull out to copy the history of all of the files touched within the repository that we were pulling out. So if you're interested in pulling a project out of a Git repository into its own, we have great instructions for how you can copy out all of the history. So if you open up one of our modules, I think we split these out. It was right before FOSDEM, because I remember I was excited because I could tell people at FOSDEM that we did this awesome thing. But let me look for one. So let's see, cgit. I know, that's one of the ones we split out. So if you look at the history here, it goes way back into 2014 and beyond. It was before it was its own Git repository, but we pulled the history out of the old config, and so now we have all the history preserved. So I invite you to look at these specifications and check them out if you're doing a similar splitting out project, because we did spend a lot of time making sure our documentation and specification were updated to explain how we did this. I think we also have another Puppet-related spec that we're working on. Where was it? Oh, so we're going to put some more stuff into Hyra, so that's one of the other projects. We're refactoring all of our base templates. Right now, we have like a base, and then a base template, and then a base server, and then a base, I don't know, everything. So it's kind of a terrible rabbit hole to go into if you're ever trying to figure out how to launch a new server and infrastructure. So we're trying to take all of those crazy base things, that monster that this turned into, and split them out. And again, we're in our specification, we're explaining how we do this. It's all at specs.openstack.org. And yeah, that is what I had. So if anyone has any questions.
Anyone?
Don't be shy. All right, I'm around all day, so let me know.
So